What if I told you that NASA, with its vast resources and advanced technology, isn't planning to land on the moon anytime soon? Considering the recent excitement surrounding lunar missions and space exploration, you might be taken aback. However, reality is more nuanced than it first appears. There are several causes for this unexpected turn of events, ranging from financial limitations to technological difficulties. Today, we'll delve deeply into NASA's lunar exploration program and learn the reasons behind an extension of the highly anticipated moon landing. The grand vision. The goal of NASA's Artemis mission was to bring people back to the moon and establish a long-term presence there. In order to investigate the moon's south pole and look for water ice, a vital resource for upcoming manned missions, the Volatiles Investigating Polar Exploration Rover Viper mission was created. The mission was supposed to launch in 2022. However, there were several delays, therefore the launch date was moved to 2023. Problems started to arise as the project moved forward, ultimately resulting in its cancellation. The rover was intended to travel across the lunar surface for a minimum of 100 days in order to collect vital information that would support NASA's preparations for a long-term human stay on the moon. With sophisticated sensors, including a neutron spectrometer system and a near-infrared volatile spectrometer system employed to investigate lunar soil composition and pinpoint the sites of water ice, Viper's scientific goals were lofty. Understanding the moon's resources as well as the background and genesis of water in the solar system depended heavily on this information. Budgetary constraints. One of the primary reasons for the cancellation of NASA's Viper mission was significant financial overruns, initially estimated at $250 million in 2019. The cost projections for Viper surged dramatically over the years. By 2023, the estimated cost had ballooned to $433 million, and further projections indicated that it could reach as high as $569 million according to NASA's budgetary regulations. Any project that exceeds its budget by more than 30% must undergo a termination review. Given Viper's escalating costs, it became apparent that the mission was in risk. Budget constraints have long posed significant challenges for NASA, affecting its ability to pursue ambitious space exploration projects. The agency's funding relies heavily on federal appropriations, which require thorough justification for every dollar spent. As a result, with various high-priority projects vying for limited resources, justifying the escalating costs of the Volatiles Investigating Polar Exploration Rover Viper mission became increasingly difficult. Ultimately, despite reassessments and approvals from Congress, the financial burden proved insurmountable, leading to the project's termination. Technological challenges. Technological and logistical challenges significantly contributed to the downfall of NASA's Viper mission, in addition to the financial issues that ultimately led to its cancellation. The Viper, Volatiles Investigating Polar Exploration Rover mission was designed to explore the moon's south pole, specifically to search for water ice, a critical resource for future human missions. However, the mission's success was heavily dependent on the development of a suitable lunar lander, which had not been created by NASA since the 1970s. NASA faced hurdles, including readiness delays, and had to rely on Astrobotic's Griffin lander to deliver Viper to the moon. Concerns concerning the launch's timeliness and viability were raised by these delays, which also made logistical problems worse. Important components for Viper production and testing were significantly delayed as a result of the COVID-19 epidemic exacerbating supply chain problems. The intricate design and requirement for extensive testing made the deadline even more difficult. The development of the Griffin lander was beset by challenges, including as pre-flight testing, propulsion system problems, and changing schedules. The mission was cancelled after the Viper's landing was moved from 2023 to 2024 due to further issues that extended the launch window to 2025. Future missions and collaborations. In order to maintain technological progress, NASA intends to reuse the instruments from the Viper mission on upcoming lunar missions. Proposals from US businesses and foreign partners interested in utilizing the current Viper rover system at no expense to the government are welcome to the agency. Originally intended to bring Viper to the Moon, the Griffin lander will now serve as a technology demonstrator, testing the vehicle's capabilities with a fake payload for upcoming missions. This action clears the way for next lunar projects while also salvaging a portion of the work completed on the Viper mission. NASA has a number of missions scheduled for the next 5 years to explore for ice and other resources on the Moon as part of its ongoing commitment to its larger lunar exploration aims. NASA is still moving forward with the Artemis program, in spite of the cancellation of the Viper mission. By the end of this decade, the Artemis program hopes to bring people back to the Moon and establish a long-term presence there. The Space Launch System, SLS, rocket, which will transport people and supplies to the Moon, is a crucial part of this mission. The SLS rocket's second core stage is prepared for shipping to Florida, where it will be combined with the rocket's remaining components for the Artemis II mission. Artemis II, which is slated to launch no sooner than September 2025, will be the program's first crewed mission, laying the groundwork for further lunar landings. Despite the many obstacles along the way, every step gets us closer to our goal. Why is returning to the Moon so important? The Moon serves as a valuable testing ground for technologies and strategies that will be crucial for future missions to Mars and beyond. Establishing a sustainable human presence on the Moon will provide insights into living and working in space for extended periods, paving the way for deeper space exploration. The role of science. Scientific research is central to NASA's lunar exploration initiatives, with missions like Viper and Artemis poised to significantly enhance our understanding of the Moon's composition, geology, and history. The data gathered from these missions will not only advance our knowledge of the Moon, but also provide insights that can benefit various scientific fields on Earth. The knowledge gained from lunar exploration is invaluable for multiple reasons. Understanding the Moon's geological processes and its evolution can shed light on the history of our solar system, including the formation and development of other planetary bodies. This research is crucial for piecing together the complex interactions between the Earth and Moon, as well as the broader cosmic environment. Moreover, the technological advancements driven by space exploration have far-reaching implications beyond the confines of space science. Innovations developed for lunar missions often lead to breakthroughs in various fields, including robotics, materials science, and telecommunications. For instance, the challenges of operating in the harsh lunar environment have spurred the development of more resilient materials and advanced robotic systems which can be applied to industries on Earth. If you found this deep dive into NASA's lunar challenges fascinating, don't forget to like this video and subscribe to our channel for more updates on space exploration. What are your thoughts on NASA's shifting priorities and budget challenges? Share your opinions in the comments below.